see exist operator. Exist operator is also one of the important related to subqueries. Just query whether existence of uh, one employee in another table, one employee ID in another table, like employee table to department table, products to order items, product ID is present or there in that same table, in that other table, like that, to find out uh, existence of some column. See, let's see with example, right? Here we have a table of products, and we're also seen and interested in the order tables here. So let's say we had the following objective. This this is the requirement I want, as given in the order details in the other words. See, products with the product ID exists in the order table, order details table. We can write this query by using exist operator, and also by using in operator also. You can we already see that how in operator will works, like that. In by using in operator, also you can achieve this, or else you can do by achieve you can achieve this by exists operator also, right? So this query, the exist operator accepts a subquery as an input, and returns if a true or false. In the true or false, if the see here subquery is there, subquery returns at least one row, then exist will evaluate to true. If no rows are returned by the subquery, then exist returns false. The database ignores the select list of the subquery because if only cares about if the subquery returns any rows or not. Therefore, it does not matter what we specify if the select list of the subquery. In this case, I just put select asterisk. See, the exist operator is typically used in conjunction with the correlated subquery. For example, this query here is correlated subquery, is a correlated subquery. We are selecting columns from products where the product ID exists, and then we have our correlated uh, subquery in parentheses. Here we have select from all the details which we are aliasing to O, where O dot product ID equals to P dot product ID. So did we get from the out of a query? See, so this is our correlation. Recall that on a conceptual level, a correlated subquery gets evaluated once for each row processed, right, by the output query. Therefore, each row in the out of query will evaluate if a true or false is given by the exists or non-existence of the product ID in the order details table. Okay, let's go for and see how each row is processed on a conceptual level. If we take the first row, the product ID equals 1. To show how this query is processing each row, rows up the product ID value into the where. See, where clause of the subquery. So when processing row 1, the exists evaluates to true because we have at least one row in the order details table where product ID equals 1. Therefore, this row gets included in the query result, like this. Each row and the products table is then evaluated in this way, right? And so 4 is there, 5 is there, true, 6 is there, true, and 7 is not there, false, 8 not there, false. Okay, so we get our 4 records in the final query result, and these are all the products which may have matching product IDs in the ordered tables, right? Another way of getting the same result would be to use the query self-contained query. By using self-contained query you can write. So if we look at both methods, so Here see, using exist and the bottom query, see products directly you can use from products where exists. Here where product id, where exists, where product id in, exists and product id in. How to use, which query is better performance? It depends on like the SQL engine might create an identical execution plan for an it does for exists. It that happens, then there will be no difference in query performance. As a rule of thumb, exists is, as a rule of thumb, like exists is faster than when the inquiry result is very large and subquery result is very large. Conversely, the operator tends to be faster when the see exist is faster than inquiry result is very large. If subquery result is, exist is faster than when subquery result is very large, right? Conversely, the operator tends to be faster when the subquery is very small. See, let's see introduction to window functions. Here exist operator, like that you can do. Let's see the Windows operator later. Windows operator, definitely in entry purpose Windows operator they will ask, do you know in any window operators, like that they will ask. Window operators, like important topic related to SQL, window operators, window functions, sorry, not operators, window functions, right? Officially introduced SQL in 2003. However, even though they have been around for a while, a lot of people still don't know, don't know about them, the window functions. I have come across many situations where someone has written some very complex SQL queries with many joins, right? And some queries which have aggregations in them, when the same result could have been achieved in a in a much simpler way by using a window function, right? Okay, let's start it. Types of functions. Here window functions, in the window functions there are three broad types of functions and SQL. These single row functions and operations, like single row functions and operations, operate on a single row at a time and returns one output per row. See, here aggregate functions. Aggregate functions operate on multiple rows at a time and returns single value per group of rows, right? Let's see later. Window functions, single row functions, aggregate functions, window functions operate on multiple rows at a time but returns one output per row. Operates multiple rows, operate on multiple rows but returns one output per row. Let's see with examples later, right? Okay, let's look at some examples here. Products table is there. We have product table and then I have changed the price for product ID 7 to 50. Here See here, in this table we have a total of 3 products in the commodity categories, right? Commodity 51, commodity 21 and commodity 51, right? Here now 2 of these products have a joint equal highest price of the $51, right? Here $51 is the highest, joint highest, right? Here okay, with that in mind, let's say we have the following objective: return all products which have the highest price of that product category. Here I want all products which have highest price with highest price for that product category. Group wise product category, group wise category, and in that group I want the highest price value. Here we have 2 values. See 51, 2 values. Previously we saw how we could achieve this by using a correlated subquery. We already know how to get by using correlated subquery, that max function, self-contained subquery. In that we achieve, right, how to get that max and all, right? Let's see here how to achieve, right? See, in previously we got like this: product at category price from products p1, select max price from products p, like this we will achieve, right? This gives us the result we wanted, like this, right? We also saw how we could get the same result by using a joint self-contained subquery. See, for example, here we are doing the aggregation in the here we are doing some aggregation. Let's then join back onto the products table. Select product 1, product p1, category from product p1, some inner join. Yeah, it's some inner join. Let's see, to get the products with the highest price in each category. Okay, so now I am going to show you how to write this query by using a window function. Let's see how to write this by using window function. In this case we will be using the rank window function. So first we add the window function to the select columns, and this query now gives the following result: select product ID, category price from products. See here, so first we add the window function to the select column, and this query now gives the following result. See, rank over partition by category, rank over partition by category. Partition is group by category, order by price, descending order. Descending order gives from maximum to minimum, right, as rank from products. It assigns see like this. We have added the rank window function, and we have at least this expression to the letters rank. I have called it rank rather than rank because rank is a keyword in SQL, right? Rank is one of the keyword in SQL, it's a best practice RNK, not to same expression, the same as in SQL. See, okay, what is this doing? Like, well, the rank window function determines the rank of a value in a group of values based on the order, by expression as specified in the over, right? So in this function we have the keyword rank followed by a open frame, first open frame and then close parenthesis, right? Then we have then we write the keyword over, and the over clause is used to define the set of rows for the function to work over, right? So within the over clause we have the keywords partition by, and in this case we are partitioning the rows by the category column, right? So in this first partition we have all the rows with the category of commodity. In the second partition we have the rows with the category value of convenience, right? Then we have niche, and finally the unassigned category, which just has one row in its respective partition, right? Okay, after that partition by we have an order by expression, and we are ordering price in descending order. This means that we are starting with the highest price, so the highest price product will get assigned a rank value of 1 with each partition. The ranking are for each partition, rankings are reset for each partition, right? Group of rows, it will be reset for each partition. If we if like two products in a particular category have the same price, then they will get assigned the same rank value. We can see that this is the case of product ID 1 and 7, which are both in the commodity category. These both have a price of $51, which is highest price of the commodity category, right? They both get a rank value of 1, right? See, now now all we need to do to get only the products which have the highest price for their respective product categories is to filter the data by selecting only rows which have a rank value of 1. So let's show that they gives uh, gives the result we wanted to summarize. We calculated the rank for each row in the subquery, and then in the subquery we have the rank equals 1 to keep just the highest price products in each partition, right? The reason why we need to put the window function in the subquery is because of the logical processing order. Recall that which in the form of clause gets evaluated first, and then after that the way clause get evaluated, right? So we determine the rank values in the from clause in the subquery, and then after that we have the rank values in the column available to us in the where clause in the outer query, where we can apply filter to keep only rank values equal to 1. Personally, I find the solution much easier to read, especially compared using a correlated subquery or a joint or subquery, or we had to do in this case which simply to use a window function, like put in a subquery, then the filter it to get the result. To get the result we wanted. See, what is this one? In this way we use rank function, window function, right? Let's see common table expression, CT expression. What is CT expression? We will see, right? We'll see CT expression in next session. Let's stop here.